Hi, this is Herb Shapiro of the Dr. Vax channel. And today we're going to talk about a way to turn your 3D printer from a producer of toys and artistic items to a producer of practical prints custom designed for your needs. Now, everyone pretty much knows that 3D printers are slow. This case for index cards, I'm sort of an old-fashioned guy. I still take notes on index cards. So this case that I printed for myself took 3 hours to print. That's a long time. If you were to create a mold for injection molding plastic, that's sort of a production way of making plastic parts, you might be able to produce hundreds or thousands of those cases an hour. Now, it would take you 2, 3, 4 days. Maybe you'd have to wait a week or two for somebody to create a mold. The mold might cost you hundreds or thousands of dollars. But if you're producing a large quantity, injection molding, it's much faster than 3D printing. So why do we 3D print things? Because we can customize them. We can print them today, now, not quickly, but today, now, to meet just our specific custom needs. I'm going to teach you how to do that. So stay tuned and let's learn together about FreeCAD. Creating a two-dimensional drawing in a computer-aided design program such as FreeCAD or Tinkercad or Fusion 360 is very much like drawing in something like PowerPoint. It's really very easy to do. But when you're creating a three-dimensional object, like this object here, you use a very different technique. Depending on the program you're using, you do start with a two-dimensional drawing. And then you extrude it, you expand it from a two-dimensional drawing into a three-dimensional shape. But if you need to modify that initial shape, you create a second shape. And that second shape is used to cut out material from the first shape. In simpler 3D design programs, that second shape is called a hole. In more sophisticated 3D design programs, often you refer to that as creating a tool that you use to cut one shape from the other. So before we get started with FreeCAD, I want to reinforce this concept of positive shapes and negative shapes and using one to cut the other. And because it's the easiest program available for doing this, I'm actually going to use Tinkercad. So let's look at the screen together. First, I'm going to take and click on and drag a box into my work plane. Then I'm going to make it a little bigger by dragging on the corners. And a little bit taller. And then we'll drag it to the center. Now, one of the advantages of Tinkercad is it's a direct manipulation program. You just grab onto the corners of an object to change its size. You click on the middle and drag to move it around. It makes it very easy to use. Most professional 3D design programs do not quite work that way. And so as an example, when I try to use a program like Fusion 360, and I've used it successfully, it's a little different for me because I'm used to sort of the PowerPoint approach where you just create an object and drag it around. Tinkercad is like that. Now, if I want to cut a hole into this rectangle, I take and I drag a cylinder into my space, and I can make it bigger in either or both directions. I can drag it into the middle of this box, and I can push it down a little bit. Now, if I group these two items together, I will have a hole in the middle of my box. That concept of creating a base object and another object and combining it with it or using it to cut a shape out of one object or another is very important to understand computer-aided design. Now, let's take a look at FreeCAD. And why bother? This seems so wonderful. Well, Tinkercad is extremely easy to use. I still use it all the time. And in fact, you can build things somewhat sophisticated. It would definitely be possible to do something like this in Tinkercad. But how would you do it? This isn't a rectangle. It's sort of a odd shape. How do you hollow it out? Well, in Tinkercad, to hollow it out, you could create two versions of the shape. One that is a solid, and then a second that is a hole, and group one in the center. You can hollow it out. But in a professional CAD program, actually, as you get to more sophisticated shapes, it's much easier. So why not start with a professional CAD program? Because they're complicated to learn. So I'm going to challenge you. Make the investment to learn traditional computer-aided design. We're going to learn FreeCAD. Many of the techniques you learn in FreeCAD could be used for a free or paid version of a higher-end program such as Fusion 360. But for my needs in creating 3D prints, I find FreeCAD is perfect. So if I need something very simple, I use Tinkercad. If I want something a little more sophisticated, I use FreeCAD. Let's look at FreeCAD now. If you go to freecadweb.org, that's freecadweb.org, you'll see the page that we see on the screen now. If you click on download, it will take you to a page to download a version for your type of computer. And these are traditional installation packages for your computer. So if you know how to install software on a Windows machine or a Mac or a Linux machine, you'll have no trouble. Now this is version 0.18, which is getting close to a year old. Version 0.19 is in beta test. It's in test. And I find it pretty darn stable. So I'm going to use version 0.19 today. How do you find it? Well, there you do have to do something a little more complex. So if software is not your thing, download this version. Everything I'm going to show you is going to be very similar. If you're into software a bit, go to github.com/freecad. And on GitHub, you'll see all sorts of FreeCAD add-ons and the latest beta version. GitHub is a sort of cloud-based repository of open source software. So I'm going to go to the FreeCAD page right here, FreeCAD. And then I'm going to scroll down here and go to the releases page. So this is github.com freecad/releases. And we'll see 0.19 pre-releases available. And down here, you'll see versions for the various operating systems. So I'm on a Mac, so I would click on this version here. Once again, this is scary. Just go to the main FreeCAD page, click on downloads, and use that version. Okay, now let's go into the program and get started with FreeCAD. So I'm going to open up FreeCAD. When you open up FreeCAD, you'll begin on the start page. Now, your version may not look exactly like this. Let me show you how to manipulate the screen to get it working the way you want. You want to go to View, Toolbars, and turn them all on for now. I'm going to turn on Navigation also. And then you want to go to View, Panels, and I recommend you turn on just the Combo View and the Report View. So let me explain the screen here. Across the top, we have tools that are specific to a workbench. What is a workbench? Well, FreeCAD is a very big program. It can be used for designing a house. It can be used for designing a case for index cards. It can be used for designing complex metal parts. It can be used for designing the HVAC in a commercial building. It can be used for designing a concrete bridge. Well, you need different types of tools for those different types of construction. Now, they're all three-dimensional design, but they're slightly different. Each collection of tools for a particular style is called a workbench. We're going to use the part design workbench because it's an ideal workbench for creating 3D designs for 3D printing. There is another workbench you could use that uses a different style called the part workbench. The primary difference is the part workbench works more or less like Tinkercad, but it's much harder to use. You really don't have complete direct manipulation. The part design workbench works very differently. In the part design workbench, you draw something and then you expand it out. That's called padding in FreeCAD. In other computer-aided design programs, it's called extruding in order to obtain a three-dimensional model. So we're going to show you how to do that. So I'm going to select here the part design workbench. And you'll see the options across the top changed in my toolbar. And we're going to look at some of the common options. Now, what is this combo view and these tasks over here? Well, in this box, you're going to see the objects, the things that I'm building. And in here, when you click on one of those things, you'll see the properties of that thing. Down here, you'll see error messages. Now, FreeCAD, because this is a pre-release, you may get some debugging error messages down below. Just ignore them. I'll show you examples of that in a minute. In the middle here, you have the start page. Now, the start page has some examples you could click on. Most importantly, it has help. So if you want to learn about, as an example, the part design workbench, you click here, and there is a user manual for the part design workbench. And it shows you in that manual all of the individual tools. So as an example, the pad tool is used to extrude a solid. Likewise, the pocket and hole tools are used to cut something out of your extruded model. So just like there's a hole in Tinkercad, there's a hole here. So before we get started with our drawing, let's go ahead and set some additional preferences. So you go to FreeCAD and Preferences. On some operating systems, it may be under File. We're going to go here to Display, and I'm going to make the marker size as big as it possibly can be. That's going to make it easier for me to see points in my drawing. And now I'm going to click on Apply and OK. Now we're going to go to FreeCAD New. And once we've created a new item, we'll see it listed in the model. It's an unnamed item. We will name it when we save it to our computer. And if we go to Tasks, it will show you the various things we can do with that item. Now, in order to do something to an item, you have to have a currently selected workbench. Once again, we want to use the part design workbench. And you'll see we'll have the part design toolbars here. I'm going to create a body. A body contains the part we're going to draw with. Now I'm going to create a sketch. Now, we could model this a couple different ways. We could draw a rectangle and extrude it or pad it up and then cut out this shape. That'd be hard to do. If instead, and this is where you start to think like a computer-aided design expert, if instead you take and you draw this shape and extrude it in this direction, then your whole model is going to be created, and we just have to cut out the inside. Now, this little area on the bottom is actually a 3D printing brim that's designed to be peeled off. I actually liked it. It made the model a little more stable, so I left it on. The reason I used a brim is this first one I printed, and here I'll show you here so you can see, it warped. See how this bent up? Now, 3D prints warp when the temperature across the printed surface varies. So you print it on the bottom, it's hot, it starts to cool here, but it's hot on the top. And conditions like that can cause it to work. Now you can fix that by adjusting your print temperature, by enclosing your printer, and by adding a brim. So for this one, I actually lowered the print temperature, both the print bed and the print, and added a brim. And this one printed very nicely. So we're going to model this on the XZ plane because Z is this way and X is this way. And click on OK. Now see this big dot in the middle? That's our origin. But when I mouse over one of these axes, or I mouse over that dot, it changes color. We're going to need to recognize that in the future when we want to connect dots together or place items. So the first thing I'm going to do is select a tool. I could select a point, a line, an arc, a circle, a cone. I could select a rectangle, a polygon, all sorts of different tools here. We're going to select what's called a polyline. So I selected that tool. And now we're going to start it right on the origin. Click once, drag, and then we're going to click on the base. So click once, and I'm clicking with the left mouse button. And then it goes up a little bit. We're going to click. And then it goes down to sort of in that kind of angle. Click. And then we're going to try to find that exactly that white dot and click on it. And now I'm going to click the right mouse button to say I'm done with the tool. So we have sort of a basic shape here. And what we can do is you can see we can move this shape around like this. Now these axes also move around. This point here is locked in place. Why? Because we started it on the origin. And this point here is locked in the horizontal direction because it was on a axis. So how do we lock the rest of these? Well, we use these items up across the top, which are called constraints. So a coincidence constraint says make 2 points the same point in the same place. A tangent constraint says align a point with a line. We have a vertical constraint, a horizontal constraint. We have a parallel constraint. We have a perpendicular constraint. We have a tangent constraint. This actually was not a tangent constraint. I said incorrectly. That fixes a point on an object. This is a tangent constraint. We have an equal constraint that would be used if you want to make two objects, two line segments as an example, equal. We have a very useful constraint, which is called the symmetry constraint. And then we can create a horizontal constraint, how long it is horizontally, how tall it is vertically, what the radius is, or the amount of arc, the angle of an arc. So these are all of the things we can constrain in a model. A perfect model is fully constrained. That means that if we go to drag it around, it will not move around. Now I'm going to show you something. I'm going to take the existing constraints that are in here and I'm going to delete them. So now there are no constraints on this model. So now these things aren't even connected together. So my model could completely break apart when I go to move it. Let's start with a simple constraint. And that is we want to take the corners and connect them together hard again. That's called a coincident constraint. So I'm going to take and click on this point, hold down Command and mouse over till that turns yellow, then click on it. So those are both selected. And I can say they're coincident. Bam. Let me do that the same here. They're both selected. Whoops. Have to hold down Command, which is Control on a Windows machine. It's Command on a Mac. Coincident. Let's fix this one here. There we go. Second one, coincident. Now, let me take and click on this line here and say it must be vertical. But now, let's make this coincident with this. Aha. And so we see it's not aligned to the origin. So we can still move this all the way around. So let's continue to fix this. Well, the first thing is we have a dimension here. And, you know, we can make that whatever we want because we're just sort of messing around here. But I made that about 40. So let's click on that line and put a horizontal dimension of 40 millimeters. And then how tall do we want this to be? Well, I would take an index card and I'd measure an index card. And it's about 75 millimeters. I want a little bit of the index card to show above the top. So we're going to put a vertical dimension here of 70. And let me scroll in a little so you can see it. And press down. Whoops. Press down and move this. And let's scroll in. Now I'm going to click here on the cube to show exactly the front view so that we can see it clearest. Now let's click on this one and let's make that horizontal. Now we're getting there. Now how big do we want this? So let's make this a dimension of, oh, this looks about right what we did here. So that was about 20. Make that about 20. And now our model looks pretty good, but it still moves around. This line's not vertical yet. Let's make that line vertical. Whoops. There we go. Our model is pretty much locked together now. It's not distorting, but it's moving around. So let's lock it in space by making this point, which is our origin, and click Command in this point, and we'll make those coincident. And now our model turned completely green. And we'll move it around so you can see it. Now, if these dimension lines are getting in your way, you can click on them and drag them out. These little points here, you'll see these extra little lines. These are showing you where there are constraints on your model. You also can go over to your model and you'll see we have a body, we have an origin, and we have a sketch. Under tasks, you can see all of the individual constraints that we've defined for this model. And if you go down a little further, you'll see all of the individual components in that model. So now let's close our model. I'm going to press on the scroll wheel and move it down a little bit so we can see it a little better. There we go. And you can see it's on the Z-axis and the X-axis. Now, we want to turn that line into this. So I'm going to click on a single element of my model. I only have to click on one edge. And let's go back here and make sure we're on that body. So I'm going to click on one edge and go to tasks. And you'll see there's a task here called pad. Pad is the terminology in FreeCAD for expanding out a model. So I'm going to pad that model, and now we have a three-dimensional shape. Well, how long do I want this to be? Well, I want it to be big enough to hold an index card. So let's make it, let's make it 135. And I'm going to use my scroll wheel to zoom out, and then press my scroll wheel and move it back. Now if I hold Shift and my right mouse button, I can rotate it around. Well, that looks great, except it's a solid. This isn't solid. Now, I could take another shape and use it to cut out this shape, create a hole. But there's an easier way that's available in most high-end CAD programs. And that is I can click on this shape. I'm going to go OK to make that pad permanent. And I'm going to look up here, and there's an item right here called Make a Thick Solid. On many other CAD programs, that's called Hollow Out a Shape. So let me click on that. And you'll see it hollowed out our shape. And I can tell it right here how thick I want my walls to be. I can also tell it whether I want my walls to be on a sharp angle. You can see that there now. Let's zoom in here so you can see the walls. Or I want them to be in an arc. And I can say make the thickness inward. So now it's adding space on the inside to create a thickness, or outside. We're going to leave it outside. So what we just created is a three-dimensional shape. And once you get this under your belt, this is a 5-minute job, maybe 10 minutes. In Tinkercad, it would be a bit longer because you'd have to manipulate the shapes in a more complicated way. So I'm going to click OK, go back to the model, and it's very important. I need to select a body. Then I'm going to go, if you don't have a body selected, what we're going to do next to save this for 3D printing won't work. Select a body, go File, Export, and we're going to call this Sample 3D Print. And down here, I'm going to say I'm going to export it as an STL file, which is the standard we use in 3D printing. Save. Now let's open up Cura and see if we can load this model in, ready to be printed. 3D print sample STL, open it up, and there we go. In Cura, I have my print ready to print. I can slice it, and you can see that at a 0.2 millimeter layer height, this object is going to take, let's see here, 3 hours and 30 minutes to print. Well, folks, I hope you learned something today. Something about the difference between direct manipulation, object style, computer-aided design programs like Tinkercad, and the power of what's called a parametric design program like FreeCAD. In a parametric design program to review, while it's not always the case, many times you start with a sketch and you extrude it or pad it to create a shape. Now, what I didn't show you, but I'll show you in the next lesson, is I can go back and change my sketch, not change my pad, not change the hollow function, the wall function that created the hollow shape, and everything will automatically change. In a program like Tinkercad, if I want to change that base model, I have to really start from scratch. So folks, I hope you learned something today. If you did, give me a thumbs up. Share this with everyone that you think might benefit from this video. And make sure you go to forum.drvax.com where we can have interactive discussions. You can post images, pictures. We can talk about all of the things that you're making. Thanks so much for watching. Leave comments below, and let's continue to learn things together.